Welcome, everybody, to the first of our 7-part series on what raises and lowers specific chemistries. This is episode 91, the first of the 7, and we are going to be talking about what raises and lowers pH. And just so you know, we cover pH in more depth in our episodes 1, 3, 29, 31, 35, 46, 70, 77, and 79. As you can tell, it's a pretty important thing to understand. So, let's go. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. pH, as a refresher, stands for potens hydrogen, but in English that's power of hydrogen, basically. It's the concentration of hydrogen ions, and so the more hydrogen that's attached to a given compound, the lower the pH, and the more acidic it is. And then conversely, the less hydrogen attached, the higher the pH and the more basic or alkaline it is. pH is on a 0 to 14 scale, where 7.0 is perfectly neutral, and every whole number is 10 times greater or less than the next whole number. So like if you are at a 6 and you go down to a 5, that's 10 times more acidic than 6. But because it's logarithmic, 4 would be 10 times 10, right? So the difference between 4 and 6 is actually 100 times more acidic. The difference between 3 and 6 is 10 times 10 times 10. That's 1,000 times more acidic. So it can get out of hand pretty quickly. Now, if you think about an H2O molecule, the hydrogen separates from it. You get this hydrogen ion, that's the acid. And then the OH, with an electron on it, is the hydroxide. That's the base. If you have an OH, a hydroxide in it, you're going to have a very high pH. Things like calcium hydroxide or sodium hydroxide. You know that it's got a very high pH. So just keep that in mind. We don't want to get too deep into that chemistry here. But I do want to bring it up because pH matters because it impacts just about everything in water chemistry. We at Orenda care about it mainly because of its impact on the LSI, though the industry has been taught what I call pH dogma, where the 3 main reasons for thinking about the pH come from the industry standard textbooks and stuff, where it's like bather comfort, the pH of your eyes or skin or whatever, corrosion and scaling of equipment, and the strength and efficiency of chlorine. And I can just debunk all 3 of those. So bather comfort, that's not true at all. I was a competitive swimmer for a decade of my life, and I've swum in pools with 6.5 pH in Europe, and it felt fine. And I've also been in horribly mismanaged pools in the United States that had higher pHs. And I know this because I can drink bottled water at 5.5 pH, and I can also drink Costco water at 9.5 pH, and they're fine. Well, that's a 10,000 times difference in acidity, and both are fine. They don't irritate me at all. Now, to the extremes, yes, a pH can itch your skin and it can burn you eventually, but it's not about the pH of your eyes. It never was. Bather comfort is about disinfection byproducts. It's about chloroorganic compounds and combined chlorine and things like that. That's what bothers swimmers. It's not the pH. So I don't buy that argument at all. If you can prove me wrong, podcast@orendatech.com is the email. State your case. I'll hear you. I'll read it. I'll respond. I'd love to know. The next one, corrosion and scaling of equipment. This involves pH, but it's not just the pH. It's actually the LSI. So this is the pH and the other factors that go into the LSI. That one I don't need to dwell on. And then finally, chlorine strength and efficiency. We really dive into this in several other episodes, but basically that's true that the lower the pH, you will have a higher concentration of hypochlorous acid, which is the stronger form of chlorine, if you have 0 cyanuric acid in your water. The moment you introduce cyanuric acid to your water, that changes everything. You can listen to more episodes about that and go on our website. Just type in CYA in our blog. You'll find a ton of information on it. We have this chart that we got. We didn't write the chart, actually. We got it from the Model Aquatic Health Code, and it clearly shows that When you have CYA in your water, the pH is not controlling the strength of your chlorine. The free chlorine to cyanuric acid ratio is. So this pH dogma that you have to have a 7.4 to 7.6 pH, not buying it very much. It really matters for your LSI though. So I'm not saying it's not important. I'm just saying it's not important for the same reasons we've been taught, especially if you have cyanuric acid in your pool. But an easier way to think about pH is to think about dissolved carbon dioxide. Again, we have another episode about this, or like 5. The more dissolved CO2 in your water, the lower your pH, and the less dissolved CO2 in your water, the higher your pH. I like to think of beer in a bottle. If you're looking at the bottle, you don't see any bubbles. But as soon as you crack that bottle open, suddenly bubbles appear, and they start getting to the top, and you get that head foam, and eventually the beer goes flat because you're witnessing something called Henry's Law. And basically all it states is any gas dissolved in a liquid must equalize with that same gas above that liquid. In that compressed bottle, you had that little pocket of air under high pressure because there was a lot of CO2 in the beer, a lot of CO2 in that pocket of air. You open the beer, now the CO2 in the beer has to equalize with the room, which is a much lower pressure, therefore it loses CO2. And because CO2 determines the pH in your pool, when you lose CO2 to natural aeration and off-gassing, your pH naturally rises. This is why we added the pH ceiling to our app. If you push show on secondary readings at the top left of the calculator, it's going to show you how high your pH can naturally go. That pH ceiling is basically how high your pH can go when your CO2 is in equilibrium in the water and the air above the water, meaning you can't lose more CO2. That's the ceiling. That's it. Just like a beer will go flat after a while, your pool is trying to go flat too. When your pool is flat, that's what your pH is going to be. Now you could get over it, but you'd have to force your pH over it. It's not naturally going to get there. So now that we've done that recap of pH, let's talk about what causes pH to increase. In order to raise your pH, you need to lose CO2. You need less carbon dioxide in your water. You can do this with aeration, jets, spillways, waterfalls, bubblers, sprayers, people splashing, you name it. That is going to accelerate the loss of CO2 and raise your pH. What else gets rid of CO2? Well, believe it or not, a salt chlorine generator will off-gas CO2 inside the cell because it's off-gassing hydrogen gas, which causes turbulence, and it off-gasses CO2. So CO2 leaves, and the pH goes up. Believe it or not, we did another episode on this, the chlorine gas that's produced inside that salt system almost perfectly neutralizes the hydroxide that is also produced, and that's basically a wash. So when you have this process, you're actually raising the pH in the pool because of the loss of CO2 generated in that cell. So it's actually the same thing. But there's another thing that gets rid of CO2. Algae. Algae consumes CO2 because algae is a plant. Plants consume CO2. So just another thing to think about. But there's also chemical additions that we can add to deliberately raise our pH. These are actually products like sodium bicarbonate, or more specifically, soda ash. 2 different products. Sodium bicarb is baking soda, and it's used to raise your alkalinity. We'll talk about that in the next episode. And soda ash is sodium carbonate, which is used in much smaller doses to raise the pH, and it'll raise the alkalinity too, just you're not using nearly as much of it, so your alkalinity doesn't go up as much. If you are a residential pool owner or a pool professional, and you do not have an acid feeder on your pool, you should probably never be using soda ash. We have it in our app for our commercial pool audience because they have chemical feeders and they may need to use it. But if you don't have an acid feeder on your pool and you're not a 24/7 treatment kind of thing, don't use soda ash. You're likely to cloud up that pool. Let natural aeration raise the pH for you. It's physics. It's going to happen. But there's also the high pH of chemicals like chlorine. Now, this is a temporary rise in pH because if you put liquid chlorine in, which has a high pH of about 13, yes, for a moment, it's going to have a high pH. And until the HOCl, the hypochlorous acid, kills or oxidizes, you're going to have that high pH in the pool. But once it does kill or oxidize, the oxygen in that HOCl gets exchanged for an electron, and you're left with HCl. That's hydrochloric acid, aka muriatic acid. It's almost a perfect neutralization. So once chlorine does its job, it actually becomes pH neutral, and a lot of people don't know that. And I got to credit people who have told us this. It is actually written in Bob Lowry's textbook. If you've ever read the IPSA Basic Training Manual, it's actually in there. It is a pH neutral thing. Same with CalHypo. But if you are not using acid every week to reduce your pH, this excess lye that is created by these chlorines will accumulate. And you'll get excess hydroxides in your pool. Let's say you're using a CO2 feeder instead of acid. It will also raise the alkalinity. We're going to get to that in episode 92. So you get these high pH chlorines, CalHypo and liquid chlorine, and then of course a salt cell raises it because of the loss of CO2. If you have other high pH chemicals, they can, just depends on how much you dose, but realistically that's not really a huge contributing factor. So the main things are natural loss of CO2 or forced loss of CO2 in the case of a salt cell, and then adding something like sodium bicarb or soda ash, or the temporary rise of liquid chlorine or CalHypo. Now, let's talk about what causes a pH to decrease. Well, in order to lower the pH in your water, if you have alkalinity in it, you need more CO2. You need more dissolved CO2 in your water. The easiest way to do this is to use a CO2 injector, but most pools don't have that. A lot of commercial pools do, but hey, if you need more CO2 to lower the pH, inject CO2. There you go. It'll lower your pH, and it will not lower your alkalinity. But the main way people lower their pH is they use acid. Acid will convert alkalinity into dissolved CO2. It will convert bicarbonate into something called carbonic acid, which is H2CO3. H2CO3 is H2O plus CO2. In other words, it's dissolved carbon dioxide. That's what lowers your pH. That's what lowers your pH. So when you put acid in a pool to lower your pH, you also lower the alkalinity because you're burning through the alkalinity to create more dissolved CO2. That's why they both go down. But if you just inject CO2 to lower the pH, the alkalinity doesn't go down because you bypass that step. Another way you can lower the pH, acidic chlorine, like trichlor, 2.8 pH. That'll lower your pH. And then other acidic chemicals, like to some degree sequestering agents or even RPR 10,000. But in the normal dosing that you're going to be using, that's going to be minimal. You're not using a ton of these products. So it's not nearly as acidic as something like muriatic or sulfuric acid or sodium bisulfate. So generally, what's going to lower it is going to be a CO2 injector or acid or trichlor. The final thing I want to talk about here is pH can also be suppressed. And in order to suppress the pH, all you have to do is prevent the natural off-gassing of CO2. We did an entire episode on this, episode 46, by the way. But essentially, you need to cap your beer. So there's one factor that we're not thinking about here. Every pool is naturally going to raise their pH, right? The pH is naturally rising, except pools with auto covers. Because an auto cover that is not mesh, and by the way, for those cover companies that might be listening to this, I've talked to several of you already. If you can make a safety cover, like an automatic safety cover that is mesh, that retracts and opens up and closes, but it's mesh to allow CO2 to escape and dilution to come in, that would be awesome. That would dramatically improve water chemistry for people with covers because pools need to respirate. It's all about carbon dioxide. If that carbon dioxide cannot leave, and let's say you have a trichlor feeder on that pool, we actually get a lot of calls about this, that pH is going to be driving down, 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 because the trichlor is driving the pH down, and the CO2 has no place to escape. The auto cover is preventing the loss of CO2. That's how you suppress the pH. Listen to episode 46 for more details on that. But to recap, what raises and lowers pH? If you want to raise your pH, you need less CO2 in your water. If you want to lower your pH, you need more CO2 in your water. And the way acid creates more CO2 is it converts alkalinity into carbonic acid, which is dissolved CO2. So I hope this explains it. If you are having questions about why your pH is going up or down, think about CO2, think about your beer going flat, think about how you could stop CO2 from moving, or what could be accelerating it. I'm Eric Knight with Orenda. This has been episode 91, the first of our 7-part series. I hope you found it valuable, and we're going to get through the rest of these week after week. If you have any questions, reach out to us, podcast@orendatech.com, or try our help center, ask.orendatech.com. Thanks for your time.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.